Continuing with our discussion of right triangle trigonometry associated with our geometry problems in section 2.4, let's talk about using the values of our 6 trigonometric functions for an angle theta for the right triangle with the given sides. We don't even have to know what the angle is. As long as we know what the sides of these triangles are, we can find each of our trigonometric ratios, all 6 of them. So first of all, let's run through the exercise of finding the lengths of our sides. You remember that for a right triangle, in any right triangle, we have a formula that tells us that if we have a right triangle with lengths A, B, and C, our Pythagorean theorem is the one that went like this. The sum of the squares of the lengths of the 2 legs is equal to the square of the length of the hypotenuse of that right triangle. So in our right triangle problem right here, we know the 2 legs, A and B, being 5 and 12. Our job would be to find the length of side C before we begin the rest of the triangle. So let's work this out. We've seen this before, so the answer should be coming fairly quickly, but let's work it through anyways. We've got 5 squared plus 12 squared is equal to C squared by this formula. So let's work it out. Let's see, 5 squared is 25. 12 squared we know to be 144. That's equal to the square of the length of the side C. 25 plus 144, when we do some addition here, comes up to be the number 169. So 169 is equal to the square of the length. We still need to take a square root. So the length of our hypotenuse will be equal to the square root of 169. Now, is this a number that we know? Well, let's think about it. What numbers could be? It's definitely got to be bigger than 12, so perhaps 13. Does 13 fit the bill? Let's see. 13 squared is the same thing as 13 times 13. And let's see what we remember right here. If we do our multiplication out, yep, sure enough, it comes out to be 169. So the length of side C, at least in this particular case, comes out to be a nice even length of 13. Okay, so what does this mean? Let's use this value. Since we know that the length of the hypotenuse of this right triangle is 13, how can we find the rest of our ratios? Well, let's work it through. Sine of theta is defined as being the opposite side of the hypotenuse. By opposite, we mean the side opposite of the angle theta. So our angle theta has opposite of it 5 and has the hypotenuse length of 13. Well, there's our ratio right there. Cosine of the angle is equal to the ratio of the adjacent side to the hypotenuse. And we can see that the adjacent side, the side right next to the angle theta, is 12. So we're going to take 12 and divide it by the length of our hypotenuse side, which is 13 in this case. Tangent of theta is the ratio that we define to be the opposite to the adjacent side. We're given our opposite side is 5, and our adjacent side is a length of 12. So we take our opposite side and place it over the length of our adjacent side, and there it is. That's our ratio for opposite to adjacent, aka tangent of theta. Cosecant of theta was defined as the ratio of the hypotenuse to the opposite side. So we're going to take our sine theta, and we're actually going to take the reciprocal of that number, 13 divided by 5. Secant was defined as the length of the adjacent side, the length of the hypotenuse divided by the adjacent side. Our hypotenuse is 13. Our adjacent side is 12. And you can see what I mean by these being reciprocals. Our reciprocal functions, cosine goes with secant, sine goes with cosecant, of course tangent would go with cotangent. So this one should be pretty easy. It's the adjacent over the opposite side. So we take 12 divided by 5. We've got our cotangent. Well, this one wasn't too bad. We can see that we got our values very quickly, but let's see what happens if we take this a little bit further here. What about some numbers that we're not as familiar with? What should we do? Well, following the same steps right here, we want to find the values of our 6 trigonometric ratios for the angle theta. In this case, if we know that tangent of theta is equal to 2/3. Well, tangent is the ratio of the opposite side to the adjacent side, so that's 2/3, and we're given that value. Cotangent, by the way, we know is defined as the adjacent side of the opposite side, so we've already got 2 of these guys out of the way. This is going to be 3/2 in this case. Well, how about the rest of them? Well, we still have to use our Pythagorean theorem. So in this case, if we call our side C our hypotenuse right here and add our 2 lengths, we're going to get the square of 2 plus the square of 3 is equal to the square of the hypotenuse side C. Carrying out our squares, we're going to be getting 4 added to 9 as the square of our hypotenuse. That is to say 13 is the square of our hypotenuse. So we're going to write our hypotenuse length as the square root of 13. Square root. This is not a nice even number either. This is not one that's going to come out to be a nice square root of 9 or square root of 25 or square root of 49 type number. So how do we deal with it? Well, in our case, what we're going to do, we're just going to ask the following. If we're asked for the sine of the angle theta, then what we're going to do is we're going to take the length of our opposite side divided by the length of our hypotenuse. And since we called our hypotenuse length square root of 13, then we can just simply write 2 over the square root of 13, and that is a perfectly acceptable answer for us. For cosine, similarly, we're going to take the length of our adjacent side, which is 3, and divide it by the length of our hypotenuse, which is square root of 13. For cosecant, we take our reciprocal of our sine ratio. So in this case, that's the square root of 13 divided by 2. For secant, we're going to get our reciprocal of cosine. So in this case, that's the square root of 13 divided by 3. And we're done. More in the next section.